Math 110 students, we've got one more thing with matrices that we want to talk about today. It involves determinants as well. All right, why are determinants coming up in this chapter on solutions to equations? And one reason is this thing called Cramer's rule. All right, so I'm going to share with you Cramer's rule real quick. And it is a method for solving systems of equations called Cramer's rule. So make a note in your notes on Cramer's rule. And let me just tell you real quick a little bit of what we're doing here with the matrices. All right. Do they only seem a complicated way to solve problems? You can solve an easier way. As of right now, absolutely. 100% of what I'm teaching you now, you could do an easier way with solving systems of equations. However, what I want you to learn is a basic method that as you go on in mathematics or engineering or business, whatever field you tend to go on into, you could understand a little bit of what's going on in the background in our method for a method of solving bigger and bigger systems of equations. All right. So all of us probably at some point in our future careers will be working with Excel spreadsheets. This is some of the math that will go on behind big business Excel spreadsheets, the solving of systems of equations, the multiplying of matrices. And there are a lot more applications of this, especially if you're going into engineering or science, probably in statistics. But also there are a lot of business applications for those of you going into business. All right. So maybe you're not going to have to do any more with matrices in your educational career, but it is to your benefit to be exposed to it. Know what the words mean and know the basic concepts. Okay. And so with that little bit of encouragement, I'm going to take you back here to Cramer's rule. Cramer's rule. All right. So Cramer's rule here. All right, Cramer's rule says you can use determinants to solve a system of equations. Okay, we know how to find 2x2 determinants. And let's say we have a system of equations, two right here, two variable. You got some coefficient ax plus by equals some constant s, and cx plus dy equals some constant t. Then your x's value will be the determinant of the SBTD divided by the basic determinant of the ABCD. Y will be ASCT over ABCD. What does all of this mean? All right, well, the best way to see this is that we're going to do an example. Okay, let's do an example. All right, so we've got 2x plus 3y equal to 1. And we are going to make 3 2x2 matrices from this, okay? The first 2x2 matrix we're going to make is probably the one that might be most obvious here, the 2, the 3, and the -2, okay? We're going to call that matrix D. And it's just the coefficients in front of the equal sign, the 2, the 3, and the -2. Then we're going to make something called D sub x. D sub x, that's going to be the determinant. And in place of the x coefficients, we're going to put the constants at the end. And so instead of 2 and 3 to start me out, I'm going to replace the x coefficients with the constants at the end, 1 and 21. But I'm going to keep the y coefficients, 3 and -2. Okay, that's D sub x. We're going to make one more called D sub y. Now, you might can guess how we're going to do D sub y. Now we're going to keep the x coefficients, the 2 and the 3, and we're going to replace the y coefficients with the 1 and the 21. Okay, and now I have 3 determinants, and I'm going to find the determinant of each of these. So D is going to be 2 times -2, -4, minus 3 times 3, which is 9. So -4 minus 9, I get a D of -13. Okay. D sub x is going to be 1 times -2 is -2. minus 21 times 3 is 63, so I get negative 65. And d sub y is going to be 2 times 21, which is 42, minus 3, which is 39, okay? So I've got d is negative 13, d sub x is negative 65, and d sub y is 39. Now let's go back to that previous slide. Our x value will be d sub x over d, the solution. The x value will be d sub x over d, and the y will be d sub y over d. All right, so what I'm saying here then is my x value solution is going to be d sub x, negative 65 over negative 13, which I believe is 5. Yep, that's 5. And then my y value is going to be d sub y, 39 over negative 13, which is negative 3. Let's check that and make sure, okay? Is my solution 5, negative 3? Well, 2 times 5 is 10, plus 3 times negative 3 would be minus 9. 10 minus 9 is indeed 1. And 3 times 5 is 15, minus 2 times negative 3, so 15 plus 6 is indeed 21, okay? All right, that worked. All right, that is Cramer's rule. Cramer's rule. All right. All right, I want you to try one, and I want you to email the solution to me at allsubwh@octech.edu. I will help you. D, the plain old one that we'll divide them both by, is 2, negative 1, 3, 2. So you want to find the derivative of, determinant of that. D sub x will be, all right, we're going to replace our x values, our x coefficient with 7 and 21. So 7, 21, negative 1, 2. All right, so find that determinant. And then d sub y is going to be 2, 3, keep the x coefficients, but now we're going to replace the y coefficients with the 7 and the 21. All right, so you can pause me there, find d sub x, d sub y. Your x value will be d sub x divided by d, and your y value will be d sub y divided by d. Email me the solution to that at allsubwh@octech.edu. All right. We can also use Cramer's rule to find a system of 3 equations containing 3 variables. Same method. Your x will be d sub x over d, your y will be d sub y over d, your z will be d sub z over d. And again, d sub x would have the constants at the end in place of your x coefficients. D sub y would have the constants at the end in place of the y coefficients. And d sub z would have the coefficient or the constants at the end in place of the z coefficients. All right, so let's try this one right on here. And I've got it written down on my sheet of paper so I can do it out a little bit easier. You know, that's always easier for me. All right, so let me make sure I've got this guy open for you so you can see it. By the way, did you know that old women are not looking their nose down at you? These old ladies looking their own. That's just such a mean thing to say about little old ladies. And I know because as I'm becoming a more and more little old lady or bigger old lady, you know why we do it is because these are our readers. Okay, and so in order for me to read closely, I have to look down so I can see under the bottom. So now you can give grace to any little old lady that you originally thought was looking her nose down at you, because she is not. All right, with all that, your new enlightenment about the problems little old ladies have reading, then let's zoom in on this one. All right, so this is a system of three equations with three variables. And what we need to do is to figure out all of our matrices. We need to figure out D. We need to figure out D sub X. We need to figure out D sub Y, and we need to figure out D sub Z. All right, D, okay. I'm drawing a matrix. I think I should be drawing just the determinant. Straight lines. My bad. Should be using straight lines, not brackets. All right, my D for the determinant is going to be 3, 2, -2, -2, 3, 5, 2, -3, -4. Okay. Remember how we do that? Then we're going to write these 2, 3, 2, -2, 3, 2, -3. And then we're going to do this thing down that way, down that way, down that way. And then we're going to subtract down that way, down that way, and down that. All right, we've got 3 times 3 times -4. 9 times -4 is -36. Plus, all right, I gotta get it. Sorry, remember this guy. 2 times 5 times 2, 10 times 2 is 20. So 20. -2 times -2 times -3, that's +4 times -3, that's -12. So we'll add those guys together, and then we're going to subtract the next group. -2 times 3 times -2, that's going to be +4 times 3 is going to be +12, plus 3 times 5 times -3, that's -15 times 3, that's -45, and then 2 times -2 is -4 times -4 is +16. So I've got, and I'll just do it all at once if I can. Okay, I've got clear, -36 plus 20 minus 12, and then minus the whole thing, 12 plus -45 plus 16, close my parentheses. All right, my very first determinant here, D, D is -11. All right, now I need to figure out D sub X. So I'm going to replace the X coefficients with the 4, -4, and 4. Keep the Y coefficients 2, 3, -3, -2, 5, -4, and I should allow myself a little more room. All right, I am going to allow myself a little more room. This is why I keep we are teaching in 2024. I should not really need old school whiteout, but I do. 2, 3, -3. So let's do our little thingy again. 4 times 3 times -4, -16 times 3 is -48. Plus 2 times 5 times 4, 10 times 4 is 14. Plus -2, -4, -3, +8, -3, -24, minus -2 times 3 times 4. -6 and 4 is -24. 4 times 5 times 3, 20, -3, -60. 2 times 16, 32. Once again, I'm going to let my man calculator do the dirty for me. Oops. All right, so I've got -48 plus 40 minus 24, then minus the parentheses of -24 minus 60 plus 32. 20. 20. All right, so I at least know my X value. My X value is going to be 20 over -11. Okay? All right, how about D sub Y? What's it -11? Did I do something wrong? Come here. Let's look. My book is saying, let's see. My book is saying I should have gotten 13. Did I do a little mistakey poo? All right. 3, negative 2, 2. Oh, that's not a negative. That's what I did wrong. All right, so let's see that. That's 2. All right, so then I should have been subtracting off negative 6 times 2. Should have been subtracting off negative 12. All right, so let's see how that fixes this. I should have gotten 13, I think. Negative 36 plus 20 minus 12 minus parentheses negative 12 minus 45 plus 16. Yep, should have gotten 13. All right. So I should have had 20 over positive 13. We can also do d sub y, and we can do d sub z. But I'm starting to feel a little lazy, but d sub y would work the same way, where you put the 4, the negative 4, and the 4 in place of these coefficients and find your determinant. D sub z, we're going to put it in front of these guys. And I'm going to do d sub z because it actually turns out to be 0. All right, so d sub z is going to be the determinant of, keep my x coefficients, 3, negative 2, 2. 3, negative 2, 2. My y coefficients, I'm going to keep those 2, 3, negative 3, 2, 3, negative 3. But my z coefficients will now become the 4, negative 4, 4. 4, negative 4, 4. Let's put these guys out on the other side. 3, negative 2, 2. 2, 3, negative 3. And let's multiply. 9 and 4. 36. 4 and negative 4 is negative 16. Negative 8 and negative 3 is positive 24. And now I'm going to subtract 24. 36. And negative 16. All right, drum roll. What do we get here? 36 minus 16 plus 24 minus all of these guys, 24 plus 36 minus 16. What do we get? 0. So our d sub z is 0. Or yeah, d sub z is 0. Okay, so then if d sub z, that means the z value is going to be the d sub z over the d, so 0 over 13, which equals 0. Now, I didn't find the y, but you can surmise from how I found the x and the z on how to find the y. Alrighty? Now, all that to say, this is a method called Cramer's rule, and we can use it to solve ever bigger matrices. All right? All right. So with that said, that concludes us in chapter 10. I think you should have all the information now. Do your homework, and you'll be ready for your quiz and test soon. All right.